Hello, Dr. Sushma Gaude. Am I audible?
Hello, sir. Yes, you are audible.
Okay, thank you. I'm Dr. Arvind Kumar from NIT Rourkela.
Yes, yes, sir.
Okay. So let me mute myself.
Sushma madam, please mute all the participants.
Yes, sir.
Good evening, madam. This is Dr. Lakshman Rao Chiru from PDU.
Yes, sir. Good evening.
Thank you very much for for your acceptance. Okay.
Welcome, sir.
So we are unable to show our this thing. No video acceptance.
Hello. Am I audible, madam?
Yes, sir.
I'm Dr. Bharat Vanose from LIT University.
Yes, yes, sir. Good
Yes.
evening, sir. Welcome.
Evening, sir. Sir, this
Good
is
evening.
Dr. Chaitanya, and we welcome you, sir. We are just starting just give a 5 minutes. Our provost sir is going to join soon.
Right, sir. I'll be waiting there.
Yeah, yeah.
Sir, good evening. Sir, Dr. Ajay Parde from JDIT Yavatmal.
Namaskar, sir.
Sir, namaskar. कसे आहात sir?
बस मजेत.
Okay, sir. Welcome, sir.
Our registrar sir has also joined the meeting. Just give me 5 minutes. So our provost sir is also joining.
I have already joined Dr. Chaitanya.
Okay, sir. Okay. So, Dr. Sushma ma'am, please start.
Yes, sir. Good evening, all. On behalf of Vidyadeep University, I welcome all to this 1 week Atal FDP, that is Emerging Trends and Research Frontier in Chemical Engineering for Green and Sustainable Future. Now, I request the coordinator of FDP and principal of Vidyadeep Institute of Engineering and Technology, Dr. Chaitanya sir, to proceed further.
Thank you, ma'am. Respected President sir of Vijyendra University, respected Vice President sir, Dr. Hirenbhai Patel sir, respected our Provost sir, Dr. Vipul Shastri sir, Chief Guest, Dr. Bharat sir, Registrar and Dean, Dr. Vilin Parikh sir, Co-Coordinator, Dr. Shishma madam, resource persons, participants, and dear colleagues. A very good evening to one and all. On behalf of Vidyadeep University and Vidyadeep Institute of Engineering and Technology, it gives me immense pleasure to welcome you all to this AICT Atal sponsored faculty development program on emerging trends and research frontier in chemical engineering for green and sustainable future, which is scheduled from 15th to 20th of December 2025. I extend my warm welcome to our respected Dean and Registrar, Dr. Vilin Parikh sir, whose visionary leadership and continuous guidance have been a strong pillar in organizing this program. Sir, we are truly grateful for your encouragement and support. I also take this opportunity to extend my warm welcome to our respected Provost Sir, Dr. Vipul Shastri Sir, whose commitment towards academic excellence, research orientation, and institutional development continues to inspire us all. I welcome you, sir. It's a matter of great honor and pride for all of us to warmly welcome to our chief guest, Dr. Bharat sir, who is Professor and Dean, School of Chemical Engineering from LIT University, Nagpur, Maharashtra. Sir, your outstanding contribution to chemical engineering education, research, and sustainable technologies are truly inspiring. Sir, your presence today adds immense value and academic richness to this FDP. We are privileged to have you with us, sir. Thank you, sir. I also extend a special and warm welcome to our co-coordinator, Dr. Shishma Madam, whose dedicated efforts and planning with constant support have played a crucial role in this successful organizing of this program. This FDP being thoughtfully designed to address emerging trends, green technologies, sustainable Industry 4.0, energy transition, advancement material, hydrogen energy, and environmental impact align with strong with the sustainable development goal. Through this expert lecture by academics from NITs, universities, and industry, this program aims to empower faculty members, researchers, and professionals with cutting-edge knowledge and practical insights. I am confident that over the next 6 days, this FDP will serve as an excellent platform for learning, interaction, collaboration, and idea generation, contributing meaningful to teaching practices, research, advancement, and sustainable innovation in chemical engineering. Once again, I extend my heartfelt hand to AICT Atal, our university management, dignitaries, speakers, and all participants for being a part of this academic endeavor. With these words, I wish the FDP great success and highly enriching experience for everyone. Thank you. Over to you, Shishma Madam.
Thank you very much, sir. It is my pleasure to introduce to all of you with our chief guest, Dr. Bhanvase sir, who is Dean, School of Chemical Engineering Department in Lakshmi Narayan Innovation Technological University, Nagpur. Sir has a very large experience in teaching academic He has total 13 number of patents, out of which 6 are granted and 7 are filled. He also published many research papers in which there are some SC and Scopus journals, that is about 111 Scopus and SCI journals, national journals, international conferences, national conferences, and book chapters also. Sir has published many books, that is 12 edited books, in which 3 by CRC Press and 8 by elsewhere. Sir has authored book published by academic press elsewhere also. Sir has total PG student guided 30 plus and PhD scholar, in which 2 are awarded and 6 PhDs are ongoing. Sir has also some R&D projects undertaken, in which 6 are completed and 1 project is ongoing. Sir also has some industry consultancy projects, in which 2 projects are completed and 2 are ongoing. The total outlay of these projects are around 15 lakhs. Sir has reviewed many international and national peer-reviewed journals also. Sir has a Best Scientist Award in RTM Nagpur University in 2017, Young Scientist Award from Science and Engineering Research Board, New Delhi in 2015. Sir has a resource person in expert talk, over 47 research talks. He also has some summer and winter schools workshop conferences attended, that is about 33. And he also work as various committee members under AICT, DT, RTM, Nagpur University, and LIT University. Now I request sir to guide the audience. Thank you.
Thank you, madam. Am I audible there?
Yes, sir.
Yes.
Yes, sir, you are audible.
Yes, yes. Officials of Vijyendra University, coordinators, co-coordinators, and participants. Actually, this topic, what you have planned for Atal FDP, that is emerging trends and research frontiers in chemical engineering from green and sustainable future. So looking at this, why green and sustainable processes which are required. Nowadays, if you look at the pollution aspect, wastewater, polluted wastewater, or air quality, or solid which is generated, solid waste it is generated. So that is in large quantity now. Suppose if you see, actually, just I am working on one in consultancy project. Now that company is producing almost 350 meter cube a day. That is the amount of wastewater which is generated, and now they are planning for suppose zero discharge concept. So that was the consultancy project. So this sustainable, green and sustainable future, how we can recycle this water, and it can be reused in the different aspects. Suppose it can be reused in industry processes or in for other purposes. So that is very much needed. So in this case, so we can think about how chemical engineering will be applicable in this green and sustainable processes. So we have seen this chemical engineering. We can modify the process. You can modify the, you can say materials, catalyst, process intensification can be done there. And then you can improve the process, and waste minimization is possible in this case. So in such cases, so that waste minimization, improved process, then so energy requirement as well as you can say waste generation, so that can be minimized. So in such courses, this type of topics what we have planned, so that is very much important. So how it can be done? So suppose if you take example of wastewater treatment, that is another problem what we have in many industries. We are facing this particular problem. So can you treat this water? In what way? What is the strategy for this? So can you recover some value-added products from that? So that is again important. That means, can you recycle this water for the usable form or in the usable form? Nowadays, suppose if you take example of sewage water, which is generated in municipal waste or municipal corporation area, sewage water. So can you recover different elements from that, or can you recover different products from the sewage water? So that can be usable. So nowadays I just look after this one research. So that is, can you recover the ammonical nitrogen or different phosphorus? So that is in the form of struvite, because in western region of Maharashtra, or you can say where heavy rainfall is there, so leaching of many minerals takes place. So in such cases, such struvite material, which is rich in different minerals, so that can be useful for as a fertilizer. So people are working on this such projects. So that is a recovery. That means, can you recover? And at the same time, in Nagpur also, in municipal corporation, that in Nagpur Municipal Corporation, they have set up the plant for sewage wastewater treatment, and they are producing the water, and that water, treated water, they are using for using in power plant, for power generation there. So water requirement in power plant, that is also reduced by a large quantity. So that's how people are thinking on this. That is wastewater treatment. Suppose second aspect, if you take a solid waste processing. So nowadays people are talking about the resource recovery. That is very much important aspect nowadays, that we should address. So in this case, sustainable manner. Suppose if you take a e-waste, can you recover different components or different elements from e-waste? So what is the process design? Can you make it sustainable? Can you have a less generation of waste during this? So that process should be or must be designed nicely. So in this case, chemical engineering role is very important. So in such cases, suppose municipal waste is generated, right? Solid waste, how can treat this? Because if you see the dumping yard in municipal corporation area, can you thought on this? Can you recover some valuable products and all these things? So that is again very important. So one more thing, that is value added product, zero discharge concept, right? So that is very important. So to achieve this, we need to intensify the process. So in terms of, you can say, design, take example of microreactor. For many chemical processes, we are using microreactor. So in that, your harsh environment can be controlled. Another thing is, you can say, you can work on the process condition in chemical plant. Then you can modify novel material, you can design new material. So that is, you can say, catalytic material that can be used, and you can improve the process by using such material. That is design of, you can see, new materials. So nowadays nanotechnology is playing very important role. So you can design different nanostructured material, so that will have a better catalytic capacity or something like that. So that is another one important aspect that we should consider in terms of process intensification. So in this case, always we are connecting with fundamentals with the industry application. So research related to industry related research on the industry related problem, that is again very important thing. So because many industries are facing many problems, so in that also we have to think in you can say sustainable manner. So in such cases, can you have different problems, and that can be resolved, that can be solved? So what I think, this such type of you can say FDP courses, where you are addressing different aspects, that is chemical engineering for green and sustainable future, or quality control and assurance, then that is corrosion prevention and control. That is another important aspect, because coating development is important task. Because suppose if you want to avoid the coating the corrosion, so coating which are suitable for marine environment or different harsh environment, so that is again very important. So that development again, it is very important. Then extraction of different chemicals from plant, so that is again one more topic that we have selected, is very well selected, and that can be important today. Because uh, can you get different products from natural sources, right? So at the same time, if you see this process simulation part, that also you have try to cover in this. Water conservation is very important aspect. In very first I told how we can plan the wastewater treatment. That means wastewater management, how can treat that, what are the processes there, because that is the major aspect you will find in municipal area, that is as well as in industrial sector. So that we need to see this. So for that, membrane technology is evolving very well, because it is applicable at the household as well as in industry. People are applying this, and RO system or so that is very well applicable to remove the total dissolved solids. So that is another important thing. Nowadays, I think green hydrogen is having more attention. So these are the different topics that you have planned. So, but what I suggest here, that after looking up this topic, or you will attend this different lectures, and what is the takeaway from such courses? So takeaway will be, you can say, you can find different research areas. You can think your research aptitude. You can have different research aptitude. How to look at different problems, how that problem can be solved, how it will be done in sustainable manner. What are the different green processes? So that type of attitude will be developed, and that will be very much helpful for the researcher as well as research scholars and the faculty members who are taking different students. So they can work on this and they can guide in that particular way. So that research aptitude will be developed by such courses, and at the same time deep understanding, so that thinking, so that will be again very important. So these are different takeaways that can be taken, but at the same time, what I suggest, the chemical engineers or the researchers should visit industry. They can find the problems, they can bridge the gap between academia and industry, and find out different problems. There are many problems available with the industries, and just if you visit there and if you go there, you can identify those and apply your fundamentals, what you have learned, or apply those fundamentals to solve such problems. So that will be very much interesting. So that is what I want to say in this today's talk, or today's talk, that is what is planned for Atal FDP. So that is on emerging trends and research frontiers in chemical engineering for green and sustainable future. So I'm very much thankful for the organizers for inviting me in this FDP for as a chief guest, and thank you. So that is what from my side. Over to coordinator.
Thank you very much, sir.
Thank you, sir, for your kind words. Now, Sushma Madam, I request you to please give the vote of thanks, and so that we can start with our first session.
Yes, sir. Again, good evening, everyone. On behalf of organizing committee of Atal FDP, I extend my heartfelt gratitude to our President, Shri Jayanti Patel sir, and Vice President, Dr. Hiren Patel. Their constant encouragement, vision, and support have been the driving force behind initiative like this FDP. I would also like to express sincere thanks to our Provost, Dr. Vipul Shastri sir, whose guidance and leadership have been inspiring us to participate in innovation and creativity across the campus. I express my gratitude to Dr. Bharat Bhanwase sir. Sir, your guidance on wastewater processing and other research area under chemical engineering throw a light on upcoming research frontiers in this area. I wish all the participants in this FDP definitely get some takeaway from your talk. I also like to extend my heartfelt gratitude to our registrar, Dr. Wilin Parekh sir, who is also the Dean of Faculty of Engineering and Technology, and Campus Director, Shri Mukund Patel sir. Your guidance and leadership have been instrumental in making this event possible, ensuring that we had the right environment, resources, and direction to conduct the FDP like this. My special appreciation goes to our coordinator, Dr. Chaitanya Singh, principal, Vidyadeep Institute of Engineering and Technology, whose leadership, commitment, and timely direction shaped the event into the success that we are witnessing today. I also thank the entire organizing team for their tireless efforts in planning, scheduling, and executing every detail of this FDP. Alongside a heartfelt mention to the technical team who worked relentlessly behind the scenes to ensure smooth operations throughout. And finally, the biggest thank to all our participants. Without your participation, this FDP would not have had its true meaning. So once again, thank you to all. Now, we move further to our first talk of the day. So let me introduce our
Before,
speaker.
Madam,
Yes, sir.
Madam,
May I do?
1 second. Before moving further, I request all the participants, please turn on your camera so that we can take photograph for this session. Register sir, I think you register sir. You want to say something?
No, thank you.
Thank you, sir. Thank you. So I request all the participants kindly turn on your camera so that we can take the photograph for this session. Shishma madam and Kruti madam, kindly take the photographs.
Yes, sir.
Join in. Camera actually is not opening from my side. I think you have to allow all.
Sir, the permission is already granted.
Ma'am, after completion the photographs, kindly let us know so that we can move further.
Yes, sir.
What is the photo? You cannot on this thing.
Sir, it's done.
Thank you, ma'am. Thank you to our respected Chief Guest, sir, Dr. Bharat, sir. Thank you to our Provost, sir, Dr. Vipul Shastri, sir. Thank you to our Registrar, sir, Dr. Vilin Parikh, sir, our President, sir, Vice President, sir, management team, and all the participants for attending this 6-day FDP. Now we are going to move further for our fourth session. Over to you, Dr. Shishma, ma'am.
Yes, sir.
Sir, meanwhile, may I?
Thank you, Bharat, sir.
Thank you. Okay.
No, no, sir. Please, sir, please. Bharat, sir, please.
Yes.
Arrange. This is in the order according to the rules.
Bharat, sir, I think you want to share something.
No, it's okay. May I leave now or should I wait there?
Yeah, you can leave, sir. You can leave.
Okay.
Thank you, sir.
Thank you. Thank you. Thank you, sir.
Thank you very much, sir.
Thank you. Thank you, everyone.
Thank you, ma'am. Thank you, sir.
Okay.
Yeah, ma'am, now you can move further.
Yes, sir. So now we start with our very first session by Dr. Arvind Kumar, who is Associate Professor in NIT Rourkela. Sir has a huge academic experience. He has several membership of professional bodies, awards and honors, which include the Scientific and Educational Research Society, MIRAT, Environmental Protection Research Award 2018. Sir also has some small sponsored projects, out of which 3 are completed, one is ongoing and one is submitted. Sir also guided the PhD students. So under him, there are total 5 PhD students and total 18 MTech students. Sir has published many international papers in international journals. So around 55 publications in international journals and around 12 publications in international conferences proceedings. Sir also has 2 book chapters and various conferences, seminars, and workshop, short-term courses attended by him. Sir also designed some short-term course organized and administrative responsibilities handled by him, in which the course named GIN course, PIC solid waste disposal, staff club president, course coordinator, etc. Sir has organized 2 conferences and invited over more than 20 lectures. So now it's over to you, sir. Dr. Arvind Kumar, sir.
Wait. Yes, it's me. So, thank you, Dr. Susma Gaude, for giving the brief introductions in this FDP.
Welcome.
And I welcome all the participants for this program. So, my lecture will be the state of the art on emerging trends and research frontiers in chemical engineering for green and sustainable futures. So, let me open my presentation.
Sushma madam, make sir as a co-host.
Yes, sir. I think sir has the rights.
Yes, I am. Let me upload it. Okay. Yeah. Window. Is it visible? Is it visible? My presentation is visible to all or not?
Yes, sir, it is visible.
Okay, madam. Wait a minute, madam. So my screen anyway. Okay, is it visible to all now?
Yes, sir, it is visible.
Okay.
Yes, sir, it's visible.
Okay, fine. How to move slides. Google Meet is sharing window. Right.
Sir, press button F5 so that it will be whole screen. The presentation will be inside the full screen, and you can use arrow key or a mouse to change the slide.
Hello.
Yes, sir.
Actually, I am unable to move my slides. How to do that? Do anybody know?
Sir, what you can do in the
Yes.
right hand side corner,
Yeah.
Uh, this means this button. If you can see my arrow button,
Which
mouse.
one? Mm,
Can you see my arrow button?
arrow button, yeah, I can see, but slides are not moving.
This one, this one. Just click this button.
My God.
Click this button, sir.
Or can anybody else control it from
Sir,
there?
for that you have to share your PPT to us so that we
I did.
can present from our side.
I have already shared the
Shishma
screen.
madam,
Yes, sir. Let me check, sir.
Shishma madam, uh,
Yes, sir.
Move options.
you can just if the sir has shared the PPT with you, you can just share that PPT or say Kruti share and make
Yes,
it
sir.
on full screen.
Yes, sir.
Mm. Is it okay?
Sir, I didn't receive the PPT.
So should I mail you or what to do? Actually,
Sir,
please tell
you
me.
just mail it to my email ID where you share
Okay.
your resume.
Okay. I'll do it right now.
Yes, sir.
All the participants are requested. Please be in this FDP only. We are just starting in a while. Just give 5 minutes. To share
Yes, I
general
am doing.
instructions.
I am doing.
We are not going to share any. Yes, sir,
Just
you can do. Not an
hmm.
issue. I am just giving general instructions to the participants.
Okay.
We will not share any external link for for the attendance and all. It will be automatically generated. Means whenever you are going to log, the log will automatically generate your attendance. After completion of this FDP, there will be a small test, as all the other participants know.
I
We'll
have
share that
sent it.
link to you all. You have to complete that. Shishma Madam, please check.
Yes, sir.
Yeah.
Just wait, sir.
Okay. I am wait. I am also searching out the way how to, if it is done as it is, then okay.
Kruti madam? Have you started the presentation, Kruti madam?
No, Arvind sir is presenting, ma'am. Kruti has not started yet.
Yeah, what to do?
Arvind sir, you please
Yes.
stop your presentation.
Yes, I did.
Kruti madam, please start the presentation.
Yes, I think it is okay now.
Yes,
Huh?
sir. Yes.
To make it
Yeah, now it's
full
done, sir.
screen.
Now you can start. Yes,
Wait.
sir.
So now, first of all, I am really sorry for this inconvenience, and good evening to one and all. Right now, the next slide. I feel very much privileged to give presentations on this topic. So this is actually the location of my NIT here in Rourkela, Odisha state. Black dot indicates. Next slide. This is the main gate of our institute. Next slide. Next slide, please. This is the building of our department. Next slide, please. So now let us come to the point. Emerging trends and research frontiers in chemical engineering for a green and sustainable futures, which actually focus on integrating circular economy principle, digitalization use of artificial intelligence and machine learning, and advanced materials to minimize environmental impact and transition to renewable sources. Next slide, please. What happened? Anyway, so now green and sustainable process development, as Professor Dr. Bharat has initially given some glimpse about that. So here the application of green chemistry and engineering come into the pictures, where we can design the process to eliminate or reduce the use and generations of hazardous substances, focusing on prevention rather than treatment. Okay, so here are the 12 principles of green chemistry is applied in the process. Okay, such as prevent waste, atom economy means material economy, less hazardous chemical synthesis, designing safer chemicals, safer solvents and auxiliaries, design for energy efficient process, use of design for energy efficiency process, use of renewable feedstocks, reduce derivatives, catalysis, designs for degradations, real-time analysis for pollution prevention. So here basically we use the AI and ML, right? Inherent safer chemistry for accident preventions. Okay, so these 12 principles of green engineering are applied as mentioned over here. Next slide, please. Now the renewable feedstock. Okay, as you see, this is in the current trend too. Okay, shifting from fossil-based raw materials to abundantly available biomaterials. Okay, bio-based alternatives such as using biomass, agricultural waste, and microalgae. Okay, these are two predominant biomass available in abundant to produce fuels, chemicals, and materials. Right. Just to convert them, we require some novel catalysts like rubidium, platinums, gold, etc. So in the recent trends, on many articles are available. You can see that based on biofeed stocks, okay, several chemicals are produced such as resins, fuels, and additives. As you know, the biodiesels is the most common fuels, and cars are available, right? Pharmaceuticals and cosmetics, bio-based plastic and recycled polymers. Next slide, please. Now the same pictures, okay, representing in what's called in the different style. Okay, agro-based feedstocks such as plants that are rich in carbohydrates, corn or sugarcane, lignocellulosic feedstock, plant that are not eligible for food or feed productions, like the logs of foods, organic waste feedstocks. Okay, these are processed in the biorefinery. Some raw material is what's called produced or manufactured, and that can be used for the productions of many things, such as plastic bottle, carpet, clothes, etc. Next slide, please. Now, the sustainable reaction media is also uh, uh, at the forefront, okay, of the research in nowadays. So here, what is done? Utilization of environmental benign solvent is used, like water, supercritical, CO2, ionic liquids, or implementing solvent-free reaction techniques. So here, as you see, given the water, ethanol, polyethylene glycol, supercritical fluids, ionic liquids, ethylenes, glycol, and solvent-free. So these are used to produce triazoles. Triazoles are basically the nitrogen-containing cyclic compounds, okay, containing two carbons. So here, the role of monochemistry plus nanotechnology comes into the pictures. So in nanotechnology, what is done? Basically, the catalyst is prepared and it is treated using the mechanical process such as ball millings, right? So process ball milling plus using what's called solid catalyst and using these solvents, we can produce the triazole compounds. Next slides, please. Hello. Next slide. Yeah. So click chemistry is just likewise. So here basically the emphasis is done on mild reaction conditions with high yields, rigorous specificity and stereo specificity. So basically what is done again, the triazoles compounds are prepared. Next slides. Instead of using harsh conditions in this click chemistry, we use the mild conditions. Now process interpretation is also at the forefront of the current research area. So here what is done, small and efficient reactors are developed which actually works in a continuous flow systems of continuous flow modes. Okay, or their size may be what's so called the, we can say, the micro reactors scale, right? And these reactors are operates at ambient conditions, reducing energy consumptions. Previous slide, this energy consumption and waste. So as you see here, process is intensified. As you see here, the purification of hydrogens. So in today's solution, we have many steps. Okay, but a company decammers concept. Basically, this is done in two steps only, right? So here, autothermal reactors for uh, CMR. Okay, so instead of using the large process, better we go for smaller process where the new materials and membrane can be used. New nano-structured, nano-architectured catalyst materials may also be used. Okay, novel reactor designs, emphasis is given on novel reactors designs. Next slide, please. Now the circular economy and waste management. Okay, this is also at the forefront and research trend if you see, particularly in waste valorizations. Okay, so here basically what is done, the concept of circular chemistry is used. Here, designing materials and products for easy reuse, recycle and recovering of valuable chemicals. As Dr. What's called Dr. Bharat Bhavan Vase already told about this, that we can recover some important items from the waste, as he has given the example of effluent treatment plants. Okay, so this is actually done in the in the closed loop. Okay, so here you see here the core component of the green chemistries are integrated, such as green synthesis, renewable sources, sustainable industries, safer solvent, pollution preventions, policy education and innovations, green engineering. All these are integrated for reducing waste, material, environmental footprint, pollution, cost, and risk that impacts on environmental, economical, okay, technological, and social one. Next slide, please. Now, here the chemical recycling and up recycling. Okay, so this is also this is also in the trend. Okay, innovating technologies such as advanced solvent based. So in advanced solvent based technology, what actually done, waste plastic is treated to produce monomer, okay, or a molecular recycling to break down the complex plastic waste into high quality raw material, overcoming the limitations of this process. So here you see the pyrolysis, hydrogenases, solvonases, and oxidative cleavages. Hello, am I audible?
Yes, sir. You are audible, sir.
But PPTs are not displaying at my in my front the screen. Where these are gone, I don't know.
Yes, sir. Just a minute.
Next, here next. So here you see the okay. Now I will consider the as a case study the waste valorizations. Okay, waste valorization means through the recycling, reuse, the waste is converted into the useful resources. Okay, so transforming various waste streams such as plastic, e-waste, municipal solid waste, as Dr. Bharat already gave the glimpse about that, into the valuable resources or energy. Okay, why to promote the waste valorization? Because of the following reasons, such as environmental benefits, economic benefits, and social benefits. Next slide, please. Actually, what happens, some font or something is creating problem. Anyway, well, now here advanced technologies and digitalizations. So here we see the application of artificial intelligence and machine learning. Okay, so for what's so called, through applying this, what actually is done, new molecules are designed. Okay, though I don't have current examples of for this as I am telling, but AI is used for AI and ML is used for the designing of new molecule too. Okay. Also, for predictive modeling of chemical reactions, optimization process, accelerating the new material discovery, and enabling data-driven approaches. So here you see AI and ML finds numerous application in chemical engineering, transforming various aspects of the fields, such as process optimization leverage, AI and ML to improve the efficiency, reduce energy consumptions, and identify optimal operating conditions such as temperature and pressure. Another one, process control employs AI-based controllers to maintain desired process variable within the acceptable ranges, adapting to disturbances and change in real time parameters such as pH control, composition control, etc. Predictive maintenance utilize ML models to forecast equipment failures, right? Schedule maintenance activities, minimizing downtime and extend equipment lifespan, such as pumps and reactors. Material discovery and design harness the power of AI to accelerate the development of new materials with desired properties, reducing experimental cost and times, right, such as catalyst and polymers. Okay, these materials quantity may be used in the reduced one, in reduced quantity. Next slides. Now the benefit of AI and ML in chemical engineering are numerous and transformative, such as number one, improved process efficiency and optimization by identifying optimal operating conditions and reducing energy consumption and waste. Enhance Second, enhance process control and stability through adaptive control strategies that maintain desired product quality despite disturbances. Third one, accelerated discovery and designing of new materials by reducing experimental cost and times identifying promising candidates. Next slide, please. Now, next slide, please. Yes, there are AI and ML has a limitation too. In the implementations in chemical engineering must be carefully considered, such as data availability. Okay, AI and ML basically works on data availables. Okay, ML is the subset basic of AI. You might be knowing. Okay, so data availability and quality can be significant hurdle as AI and ML models heavily rely on sufficient and unbiased data for training. Okay, so that input is very important. Interpretability and transparency of the complex models, okay, such as deep neural networks, may hinder trust and adoptions in critical applications. Generalization and adaptability of the model trained on specific data sets may be limited when faced with new or unseen situations. Right. Integration with existing systems and workflows can be challenging, requiring significant changes to infrastructure and ensuring compatibility. Next slide, please. Now here you see digital transformations and industries 4.0. So now you look at that. Let us say industry 1.0. What does actually it means? Where that time there was no automation at all, no electrifications, etc. Okay, so basically here, okay, industries were rely or working on the using the mechanization process, okay, and the introducing of steam and water power. For example, textile industry. Now after that industry 2.0 comes where the industry start operating, okay, using electricity. So here the mass production is done, okay, mass production assembly lines using electrical power was done. Now the third type 3.0 industries is basically what? Automation productions, use of computers, IT system and robotics. Now industry 4.0, these are actually the smart industries and advanced industries. Okay, so here autonomous systems, okay, where IoT is, I mean Internet of the Things, and machine learnings are used. Okay, so cyber security is also provided using AI and IoT and so many things. So here basically what is done, integrating IoT sensor, cloud computing and advanced automation to enable real-time monitoring, process control and predictive maintenance, enhancing efficiency and safety of the chemical industries. Next slide, please. Yeah. So here you see the ongoing digital transformations of manufacturing and industrial process, merging physical operations with smart digital technology like AI, IoT, big data, and cloud computing to create smart factories that are interconnected, automated, and self-optimizing for enhanced efficiency, flexibility, and data-driven decisions. Okay, so here you see, as in the pictures, okay, all these components are used, such as here integration of the things, cyber security, cloud computing, additive manufacturing, augmented reality, big data, okay, autonomous remotes, and simulations. So all these actually are integrated in control loop. Next slide, please. Yeah, here digital twins. So now, as you see in the schematic of the digital twins in the chemical industry. So here basically the chemicals industry is reshaping process, optimizations, operational efficiency and safety management. So here what is actually done in digital twins, critical virtual replicas of physical plants and process to simulate and test sustainable modification and optimize operating without disturbing the actual productions. Right. Next slide, please. Now here the energy transitions and new materials. So basically here this is also at the forefront. You might be knowing that the carbon capture, utilization and storage. Okay, so this is also in the current trend. Okay, at the research front. So here what is done, developing efficient materials such as metal organic framework, in short we call it MOFs, and process to capture CO2 emissions and convert them into useful chemicals or fuels. Like as you see in the pictures, okay, there are the various sources of carbons and power plants are the predominant one. So CO2 that is emitted from the power plant is captured, okay, and it is stored, means compression and liquefaction is done, and through ship it is transported to the storage where in the depleted oils, okay, at oil drilling wells, okay, CO2 is uh, used as a filler materials in depleted oils. Or now the utilizations, as you know, CO2 is also utilized for various purposes such as, okay, CO2 and what's so called CH4. Okay, if CH mix using CO2 and CH4, so methanol production is done. CO2 that is also used, okay, combined with what's so called ammonia to produce urea. Okay, so applications, I mean the utilizations, capturing and utilizations of CO2 is the also at the forefront. Okay, now the next slide, please. Now here the green hydrogens, as Dr. Bharat has also uh, told something about it, right? So there are various type of the hydrogen, such as the gray hydrogen, blue hydrogen, green hydrogen, and pink hydrogen. So what actually is the green hydrogen? In green hydrogen, but what actually is done? Water molecule is split into hydrogen and oxygen using renewable energy sources such as solar, wind. Okay, so whatever hydrogen is produced, we call it the green hydrogen, which is the clean fuel. Okay, the rest hydrogen, gray hydrogen, blue hydrogen, pink hydrogen, they are actually not what's so called the green hydrogen. It is because, okay, they are coming from the different processes. Let us see the pink hydrogens. So in nuclear power plant, you see electricity is used, okay, in electrolyzer to split water molecules. So that means it is generating some waste. Okay, so that's why it is pink hydrogen. So green hydrogen is basically what? The hydrogen that is produced without creating any secondary pollutants, primary or secondary pollutants. So in green hydrogen, the pioneering cost effective production methods for green hydrogen, a clean fuel and energy storage solution for industrial decarbonizations. Next slide, please. Now the biocatalysts and enzymes engineering. This is also at the forefront. Okay, forefront in biochemical engineering as well as in the chemical engineering too. So here what is actually done, to native enzyme is customized as per our needs, that we call it engineering enzymes. So protein engineering approaches, there are several steps such as substrate engineering, medium engineering, immobilizations, structure guided engineering, directed evolutions, and computations designings. Through using these approaches, okay, whatever natural enzyme or bacteria is available, that is customized as per our need to create the desired product. Okay, so nowadays it is also at the forefront. So you might have heard the name of the biohydrogen. Okay, so for producing biohydrogens, okay, so the different type of the bacteria, okay, that is engineered one is used for these purposes. Next. Now here the advanced and smart materials. So basically these are those material which actually changes its properties upon little change, such as properties such as shape, color and stiffness. Okay, so these materials are also used to produce the chemicals. Okay, so here the focus is done on developing novel materials like sustainable nanomaterials for catalysis and water treatment and self-healing or stimuli response polymers to enhance durability and recyclability. Okay, so such as the piezoelectric substances and magnetostrictives, chromics. Okay, through the various process, okay, the material is prepared. Next. So now let us take the case study of dairy wastewater. Okay, how we can produce or how we can valorize the dairy waste and how what kind of the products we can obtain through this. Okay, so this actually basically work on the waste to wealth. Okay, or you can say waste to energy or something like that. Okay, so if you see here the dairy industry, okay, so the product and byproducts are like this: butter, cheese, paneer, yogurt. These are the products, right? And what's so called buttermilk, whey, etc. These are the byproducts. So here the concept aims, okay, to promote a future sustainable lifestyle where the waste valorization is seen not only for its intrinsic benefits, okay, to the environment, but also to develop the new technologies, livelihoods and jobs. Okay, so the waste valorization is the process of converting waste material into the useful products such as chemical materials and fuel. Next slide, please. Now, if you see the global productions of the milk, it is around 843 million tons as per the Food and Agriculture Organization's data of 2029. Okay, and you see here the what's so called schematic diagram for the dairy waste pre-treatment and their derived value added products. Okay, so milk is processed, milk dry products, dairy waste, and these are the some what's so called valorization process where we can get biopolymer, biochemicals and biodiesels. How, we will see later. Please next slide. Now in this we will focus on the dairy waste is a great source of biodegradable feedstock for sustainable production. Microbes can valorize whey waste from a dairy into bioplastic and biosurfactants. Dairy waste is a beneficial substrate to cultures microbes for the biofuels production. Integrated strategies for the dairy waste valorization can drive sustainable growth. Next slide, please. So here we see the treatment of the dairy waste is concerned. There are two methods: physicochemical methods and biological methods. Biological methods are cost effective and environmental friendly due to rich in organic natures of the dairy waste, make it a valuable feedstock for the productions of value added products. Next slide, please. So here are the dairy waste water can be treated in various reactors, in aerobic and anaerobic reactors, such as activated sludge process. This is process, not a reactors. Sequential batch reactors, moving bed reactors, completely stirred tank reactors, upflow sludge anaerobic blanket reactors, fluidized bed reactors, wetlands and co-compostings. Everybody know what actually is the co-compostings. After the treatment, whatever solid material is left is sent for the composting. Next slide, please. Now here there are many factors that determine the efficacy of the bio-based techniques, such as substrate type and characterization is one of the most important parameters. Operational parameters also play very important, such as what is the optimum temperature, performance of the microbe themselves, right? So anaerobic conversion of dairy waste is significantly impacted by the cytotrophic activity, means cytotrophic bacteria of the microbes active in different phase of anaerobic digestion. Next slide, please. Now here you see, through using this bacteria Saccharomyces cerevisiae to produce ethanol. Okay, so dairy effluent has been demonstrated to be the beneficial substrate for enzymatic hydrolysis, where we can produce the ethanol, right? Now the enzymes produced by filamentous fungi can hydrolyze complex hydrocarbon present in dairy waste into simple sugar. Next slide, please. So hydrolysis of lipids, actually hydrolysis of lipids during the anaerobic digestion of fat, oil-rich dairy waste inhibit the overall process, which can be overcome by the addition of enzymes. Okay, the formation of sludge in aerobic treatment can be a potential inhibitor to large scale implementation as the remediation costs become higher along with its ability to absorb toxic or and organic materials from the feedstock itself. Next slide, please. So here is the most important slide here. What actually you see here, the dairy waste, dairy industrial waste and byproducts. So predominant components in dairy waste are lactose, fat and proteins. Lactose is broken down into glucose and galactose. Fat is broken down into fatty acids and glycerol, and protein can be broken into amino acids. Okay, so their valorizations of all these broken products can be done through the anaerobic digestion, such as glucose and galactose are converted into volatile fatty alcohol, lactate H2CO2, acetate H2CO2, biogas CH4. Right, aerobic cultivations for the fatty acids and glycerol, okay, can be produced. Using them can be produced bioethanol, organic acids, enzymes, bacterial cellulose, biomass and pigments. Similarly, for fermented products and galacto-oligosaccharides, so these are basically what nutraceutical products, okay, functional food additives, etc. Next slide, please. Next slide, representing this in different form, the same interpretation. Next slide, please. Yeah, so here the value added product from the dairy waste, you see biofuel, bioplastic, organic chemicals and single cell proteins. Okay, biofuels further from biofuel further we can get such kind of fuels like ethanol, butanol and hydrogen. Bioplastic, PHA and PHB, these are actually the biodegradable plastics. Okay, organic chemicals such as lactic acids, okay, and these are corresponding strains or bacteria that are used in the process to produce all these chemicals. Next slide, please. So here are these are the actually the plastics such as PHB, PHP, BH, bioplastics. Next slide. Now the biohydrogens. Okay, so integrating the production of methane with hydrogen from the biodegradations of organic waste such as dairy, food waste and other organic industrial waste has been rooted as the next stage in developing green energy from the waste. Okay, so here sometimes we follow the two-stage approach, integrating reductions of dairy wastewater pollutions with bioenergy generations, right? Bioenergy generations means methane and hydrogens via two-phase process has been shown to be the cost-effective and highly productive process in the energy recovery. Next slide, please. Next slide. Yeah. So here this slide indicates, right, the production of bio-based products from dairy waste. Here the different type of substrates such as dairy wastewater. So biohydrogen can be produced. This is the yields that is given, and these are the responsible bacteria that help in producing biohydrogens. For so many substrates, there are so many corresponding products such as what's so called scotta feedstock from cheese, okay, bioactive peptides, bioplastic, etc. Next slide, please. So biosurfactants. So these kind of the surfactants such as sophrolipids, raminolipids, all these kind of this what's so called surfactants are also produced from the dairy wastewater. Next slides. Now here the productions of the organic chemical from dairy waste using microbial fermentations. So substrates, corresponding microorganisms, and the products. You see here what's called that succinic acid, propionic acid, lactic acid. All these important chemicals can be produced, okay, to valorize the dairy waste. Next, now about bioplastic I have already told. Okay, so the amount, extracted amount can be as high as 60 gram per kg. Next slides. Now bioactive peptides from the dairy way using methods such as a proteolytic activity of microorganisms and starter cultures and enzymatic hydrolysis by the digestive enzymes. Okay, now here you see the carotenoids have also been produced from the dairy waste such as beta carotene, gamma carotene, and lycopene. So these are basically what nutraceutical products. Now you see these are very important one. Lycopene is one of the medicine that is you might be knowing about all that. Next slide. Next slide, please. Now here the gap and further research directions. The efficiency and yield of bioenergy is the very dependent on the process parameters such as temperature, pH, co-substrate, mode of operations, and reactor configurations. Multi-channel approach would not only reduce the burden of the waste disposal at an industry level, but also provide additional source of income for the plant. The productions of the organic acid from dairy waste, there are a lot of variability in the process. Okay, because the waste is obtained from the different sources, and a large dependency on process parameters to successfully produce acids, and so on. Next slides. Economic feasibility of dairy waste valorization, one of the most important. Okay, in waste valorization. So handling and treated dairy waste currently accounts for up to the 60% of total operating cost in process unit. Okay, the key economic indicators profitability increase through integral valorizations, processing both main products and byproducts like whey can increase the dairy producer profits by approximately 24.3%. Now the investment payback periods, biogas production, as you know, it's a well-known product of the dairy dairy industries. Okay, payback periods are typically less than 10 years when digesting dairy waste with manure. Next slides. Now feasibility by products, okay, through the biofuels, biosurfactants, and bioplastic. Now you see here the integrated. Let us see in case of the bioplastic. Integrated process can achieve a minimum selling price of 2.41 per kg with optimized solid loading, 30% yielding, and internal rate of returns of 11.95%. Right. And you also know that here the biofuels can be produced at the rate of $4.78 per gallon using yeast fermentations. Okay, next slides. Now the major economic drivers and constraints. So scale of operations. Okay, so the most valorization techniques require high volume greater than 200 meter cubes wastewater per day to remain profitable. So this is one. Second, the product pricing must be comparable with the market one. Third, centralization versus decentralized. So the decentralized high quality valorizations often performs better economically when transport cost of heavy liquid waste are high. Waste profit variability in inconsistent nutrients level in the dairy effluent can complicate process designs and increase cost. Next slide, please. Now, conclusions. So, microbial treatment techniques developed in the recent past are the what's called progressing the conversion of dairy waste into the useful products. Anaerobic treatment can directly convert the waste into valuable energy resource, whereas other biotechnological methods can use it as a substrate for the production of other value-added products such as biosurfactant, bioplastic, and biomolecules. These strategies are promising circular economy and reducing the impact of waste disposal on the environment. Next slide. Thank you. Or can you move fast the next slides, whatever are available? So here this is what's called the ceramic sludge. Okay, so various valuable value added product can be produced from this. Next slide. Another example is of food waste valorizations. Next slide. And here next slide. Here you can see the spent coffee. From the spent coffee we can what's called derive the several chemicals such as lipid, polysaccharide, phenols, caffeine, and tannins. Next slides. And we can produce the various products. So water pollution from fly ash, next slides. In our country, huge amount of the waste fly ash is generated. Next slides. So what we can do, we can obtain the zeolite. Zeolite is one of the most important materials. Okay. And now it is in the research trend and very costly one, and it is used to absorb various gases. Okay. So that can also be recovered from fly ash. Next slide. Next slides. Next slides. Next slides. The same thing. Now, the waste to energy concept is basically again to recover some value added chemicals from waste. So basically, this work on the principle of circular economy and valorize the waste. Next slides. I think this is done. And the waste tire pyrolysis. Okay, this is also in the trend, and many locals small plants are available at different sites. And since Gujaratis brothers are what's so called, they are well versed in doing business, so they might be knowing this, whether some valuable products can be recovered from the waste tire or not, right? So this is also well established. We can get value added products from waste tires through the pyrolysis. Next slides. So I think this is done. Next slides. I think my presentation is over. Okay, so this is, I am showing that from the very different kind of the waste, different kind of the value added chemicals can be recovered. Thank you very much for your kind patience.
Thank you, sir, for
Yes,
your
so
insightful talk. Participants, anyone has any question? Participants can ask their question.
Good evening, sir.
good evening. Yes.
So is it implemented at your research level or commercial level?
Which one?
Huh?
Which one?
This process.
Waste valorizations of dairy waste.
Yes.
But you will not see it frequently. Okay. Particularly you see it dairy industries, let us say, in Europe. Okay. So they
Not in
usually, pardon?
In India, actually, is there
In
any
India,
implementation of this?
if it will be available, then maybe it will be what's so called, maybe in Surat, in Gujarat. Okay, where you see, the Amul industries.
Sir, I am in Gujarat. Once you visit to, I'm Dr. Lakshman Rao.
Okay.
From Pandit Deendayal Energy University, Gandhinagar, Gujarat.
Okay.
So actually, I am best friend of your colleague, Dr. उसका नाम क्या है? He did in is
ये घनश्याम बर्मन.
chemical engineering.
घनश्याम बर्मन ना?
Yes, sir.
He was my student, MTech students.
No, PhD. Friends, your colleagues.
Can you name? I don't know. If you name, then I can.
Sujit Sen. Sujit Sen.
Yes. He is my
Yeah,
colleague.
I am one of his best friends, and also I was the same
Hmm.
lab student, research scholar.
Okay.
He was my senior.
Yeah.
Okay.
Hmm.
Yeah, this process is very nice, but actually we have to see the large scale production.
Large scale
Okay.
production basically mainly depends on economic feasibility. Economic feasibility is
Because
one
here
of the
in
challenge.
Gujarat,
Yeah.
there Amul dairy is a major
Yeah.
produce
Hmm.
this thing. So
Hmm.
the dairy waste can be produced much that can be implemented here.
Hmm. Yes,
Laboratory
correct.
scale we can develop, but the thing is once it is applicable, then we can understand what is the profitable.
Exactly. That's true.
Yes.
You are right. That's why, the what's so called research, matlab recent trend and frontiers. So
Yeah.
trend means once we have started journey, then definitely we will reach to the destination not today, then tomorrow may be possible,
But
right? But we have to integrate the, let us say,
yes.
anyhow we could integrate the dairy industries, then it is
Mm,
possible.
mm.
But finally we have
Another
to
thing is
focus on
when
economic
we implement
feasibility.
any process in the Gujarat,
Hmm.
first the investors from the Gujarat always they expect the profit
Yes,
return
definitely,
on
definitely.
investment.
The
Even
professor, the
my student, many of the students always see
hmm,
that.
hmm.
So I wanted to be
Businessman will
entrepreneur.
always focus on profit. He
Yeah.
don't care about the pollutions and
No, as
etc.
in
etc.
pollution, environment, no, not at all. Actually.
नॉट एट ऑल. उसको
Uh,
केवल अपने प्रॉफिट से मतलब है, बाकी चीज़ों से कोई मतलब नहीं. वाटर बॉडीज में कुछ भी हो,
they say
जो
that
मर्जी.
we have to be take the process eco-friendly and green this thing.
या राइट.
As per the cost consideration, they never come forward to invest
करेक्ट.
in this.
करेक्ट.
Even if they invest 1 crore, and they should they expect within 1.5 years that a return of investment.
रिटर्न ऑफ
Okay,
इन्वेस्टमेंट, राइट, करेक्ट.
I have talked with many people here. I basically from chemical engineering. I'm working on catalysis here.
But now you
So
see the
my daughter,
situation what happens in the winter at Delhi. Any
yes,
people are
yes.
just, the Delhi is just like, what's so called the gas chamber, you know.
Mm.
So finally, if we will ignore the environment because we are living in
Mm.
the environment, ultimately
Mm.
we will punish ourselves.
Yes, sir,
है नहीं,
obviously.
कोई बच नहीं पाएगा इससे.
Yes,
अगर कोई वेस्ट वाटर प्रोड्यूस कर रहा है तो आज नहीं तो कल वो भी पिएगा,
yes,
और
yes.
उसको उसके कॉन्सिक्वेंसेज ही हैज टू फेस.
Yeah.
Okay, poor people will face early, but later or sooner they has, matlab industrialist or the what's so called profit making bodies, they will also bear
Mm.
the consequences.
No, they don't want to see the consequences after some decades.
Hmm.
Okay, they
Hmm.
wanted to get profit in this in
Hmm.
their time.
Hmm.
Actually, they
Correct.
right.
Right. Absolutely correct.
Futuristic plan नहीं है किसी का actually. That is what I wanted to openly say with all
डेफिनेटली
my
यू आर राइट. हम बस चले जा रहे हैं, क्यों चले जा रहे हैं हमको पता नहीं है.
हाँ.
है नहीं.
They don't
हम,
want to do. So now
नो
they are
नॉट एट ऑल.
investing. They wanted profit. That's all.
We are talking big thing on presentation, but at ground level,
Yeah, I'm very
I am
happy
honestly
to your
speaking, we are nothing.
yeah. I'm very impressed with your work and research, whatever it is done, and it should be taken up in a large scale and for this nation a benefit level as for the environmental concern. Okay.
Thanking you for this, we require money. Sponsor will not give us so much money because we are the
Yes,
NITs. If I would be in IIT system, so definitely I
definitely.
could have get the project of more than 2 crore or something like that.
How
But
how
in
is my
NIT,
friend, my senior Sujit Sen?
hmm,
Is he enjoying there?
hmm. Yeah, he became professor. He's enjoying, no problem.
Okay. So we is heading the department, sir, now?
Professor Susmita Misra is
Uh,
the current head.
Sorry
Okay.
to interrupt you, sir. Our
Okay.
Yes,
next
Thank
ma'am.
you.
session is about to start.
Okay.
Okay. Thank you very much, sir.
Hmm.
Thanks for your time.
Yes,
And thanks to all
anyone
of you.
has any question? Yes, anyone has any question, you can ask.
You listen this type of things.
Probably this is the what's so called side effect of online presentations. People have joined and might be doing something different.
Okay,
Whereas
so
people are
now
interested.
on behalf of organizing committee, I thank Dr. Arvind Kumar sir for their valuable insight on chemical engineering frontier. Sir has very well explained the wastewater treatment, the AIML use in chemical engineering, digital transformation and Industry 4.0 aspects of chemical engineering, energy transition and new materials, green hydrogen, advanced and smart materials are also explained by Sir very well. The case study on dairy waste to value added byproduct is very well explained. I hope all the participants has gained the knowledge about all the things that you explained, and they might find their upcoming research area, and whatever research they are ongoing, they can get some insightful from your talk. Thank you very much, sir.
Thank you, madam. Ma'am, may I leave? Actually, I am suffering from fever.
Yes, yes, sir.
So,
Yes, you
right?
can leave.
Okay, thank you very much.
Thank you very much,
Thank you.
sir.
Thank you all.
Now our next speaker is about to join. I request all the participants to be present in the meeting.
Hello, my voice is audible?
Yes, sir.
One.
Hello, sir. I welcome you on behalf of the organizing committee. Today we have with us our next speaker, Dr. Vijyendra Kumar, who will guide us on water conservation. Sir has a very huge experience in academics. Sir is currently working as a head of department and associate professor in Raipur Institute of Technology, Raipur. Sir has also certified water auditor. He is conducting water management and auditing. Sir also published various book chapters. There are around 12 book chapters which he published in various international books. He also has several research publications in various international journals and international conferences also. I request sir to kindly proceed with the today's session. Thank you.
Thank you. First of all, thank you to Vidyapith University for inviting me for this important lecture, and also thank you to Dr. Susma ma'am. Thank you.
Welcome, sir.
Okay. So, okay. My screen is visible to all?
Yes, sir, it is visible.
Okay, thank you. Okay, so our today's what we can say the sustainable future thing that we can say that topic is water conservation. So in the today's session, we will try to understand why this burning topic is so important, and what are the methods or techniques through which we can conserve the water, and what are the current scenario, right? So step by step, we'll see all the things. So as we all aware with the availability of water, only we'll talk about the availability of water. We have only 1% among this 97.5%, that is saline water. And if you see the remaining percentage of water, that is 2.5. So how this 1% is remain? So that 1% is coming after means the glacier and leaving the means groundwater. So the available surface water we can consider that is 1%. And if you see this graph, how the population is growing from, if you see the year 1900 to 2025, that is growing exponentially, right? And at the same time, if we'll try to understand the demand of water, that is also growing at exponential way. So both are parallelly growing at the means exponential way. So once in a while, also you have heard about that maybe the third world war will happen due to this water shortage, right? So we can understand this with this graph, how where our requirement is means necessary, right? And if you see the demand of water in different states, you can see it in different states like Tamil Nadu, Gujarat, Maharashtra, Uttar Pradesh. You can see the number of factories where huge amount of water are required. I have visited a few industries, and then according to the statement, I got surprised that they are continuously running their bore wells for the number of years. कभी कभी ऐसा होता है जब मुझे लगता है कि मेरा घर का जो बोरवेल है अगर 5 मिनट के लिए एक्सेस भी अगर चला जाता है तो आई एम वरीड अबाउट दैट हाउ मच वाटर आई वेस्टेड and the number of industries, they are flowing a huge amount of water and using and misusing, we can say, right? So if we'll ask what is the means what are the factors that create the demand, so that one of the reason is that that is lifestyle, second one in industry, and inefficient use. So if we'll say the lifestyle, how we can define this lifestyle or link with this water demand, right? So in the previous decades, lots of peoples, they are bathing or for many works, they have a ponds or lake, a kind of thing. But now the people, they want their home or their own infrastructure. And apart from there, many things through which the requirement of water is highly high. And the second, I had said that the number of industries is also increasing day by day, right? So that one of the major factor also, the demand is increasing. And third one is insufficient use. So how we can relate this insufficient use of water? So inefficient use. So if you see the industries, government policy says that you have to work on the ZLD, zero liquid discharge, but the industries cannot afford, or not only we can say the afford, there are many factors. So for example, they can't afford with the financially, but some industries are there, they have a capacity or they have financially sound, but due to what we can say that they are getting the or preventing some financial point, they are not utilizing these technologies or HTP kind of thing or ATP kind of thing, or some equipments are like multiple effect operator or cooling towers, or many other utilities are there. They are not ready to install or ready to install or implement these things to save the water. So these are the things through which we can understand how this water demand is increasing, right? So now we'll try to understand the key issues facing water resources. And among these current challenges, we can see the population growth and rising demand. We have earlier slide, we have already seeing the population growth, right? So definitely with the population, the demand will be increased 100% surely, right? At that same time, if you see the second factor, the challenge is the pollution of water bodies. See, definitely the population will increase, the requirement will be increased at the same time. We need a clothes, we need the toothpaste, we need a cauldron, we need entertainments, various things are there. So for that, definitely the need of industries, and at the same time, the industries need the water. We also aware that the government policies say that you should use only the surface. You don't use the groundwater. But many industries are using continuously bore water, so that is one of the major reason or current challenges we can say. And third one is climate change impact. So droughts, irregular rainfall, and the melting glacier disrupt water availability. So these kind of things also impact the water availability, right? And as we can say this, the groundwater depletion. So every house or every industries or every society had their bore wells, right? So day by day, definitely they are using or implementing the conservation of water. They are just extracting the water. So 100%, I'm sure that it's very difficult to save the water if people are continuously abstraction without using or implementing the things, right? And as I said, then inefficient uses. So waste through outdated irrigation methods, leakage, infrastructure, and careless practices. So this is also one of the major reasons. Like now the various things like mm, very many equipments, if you compare the Indian equipments or Indian technology with the German or US or Singapore technology, so we can also say that we are in the backdated, we are using a backdated technology. So that is also one of the reason to that we can't conserve our water, and that shows the inefficiency of us, right? Now, we see why conserve the water. Definitely, this is a future tech security. हम आने वाली पीढ़ी को हम अपने आने वाली पीढ़ी को क्या दे सकते हैं, है ना? That is future security. So some peoples are just living for their own way or own style, right? So they are not bothering about their upcoming generations. So if you see their your future generation, if you want your future will survive smoothly, so for that we have to conserve the water. At the same time, if you follow the conserving the water, right, so at the same time will definitely be save the energies for, in terms of pumping or in terms of electricity, right? And if you save these energy and secure the availability of water, so definitely we'll protect our environment, because many rivers or ponds are there. Industries are continuously throwing this water without treatment. So the pollution will get high with this polluted water, and the availability will be less, right? And one more most important information that government forcing that the industries should utilize recycle the water and use the integrated things, or use centralized treatment or closed loop system. But as for information, I would say that the agriculture part, around 70 to 80% water, the agriculture part is agricultural area is utilizing. So we have to also look into this area where how we can minimize this water, because the major area is agriculture, where the most of the huge water we are using for the production of crops, right? And last one is the industrial efficiency. So reduce cost and improves process sustainability. We have to work on this the cost of technology, and improve the efficiency of our obsolete equipment, so we can develop the industry in the sustainable way, right? Now, what are the key techniques through which we conserve the water? There are various techniques through which we can conserve the water, but the most important part of the conserving the water is rainwater harvesting. Most important part is rainwater harvesting. Through the rainwater harvesting, we can save water for our upcoming generations. So that, as I have said, that the security issues of security for the future, right? So only this rainwater harvesting we can up to at the certain level we can cover up this means the availability of this water. Second one is efficient irrigation. So as I have said that the agriculture part is agriculture area is using huge amount of water. So we have to use some technologies or like drip irrigation or sprinkler system or some other way through which we can utilize these things and reduce the consumption of water in the agriculture area, right? And the next one is recycling and the reuse. Now the industries are various equipments and instruments are using through which they are means utilizing the same water again and again. So through which we can again we can reduce our utilization of or usage of water in the industrial area. Next one is the leakage control. We visit different industries and we found that there are various leakage in their industries. So if we'll see their uses of water, so 100 KLD or 200 KLD, 300 KLD, 400 KLD. So in that case, they if we calculate the their leakage pointer, so we find that around 10 to 20 KLD they are misusing, we can say that the misusing or they are not conserving these things or not finding or not they are they are care about this leakage, so they are wasting unnecessary around 10 to 20 KLD per day, means kiloliter per day. And the last one is the water efficient appliances. So if you talk about the agriculture area, if you talk about the industrial area, but we have own responsibility. What are the things we can do in our homes? So that is use low flow faucets, dual flush toilets, and efficient washing machines. So these are various techniques through which if we take the oath in single as a single person, so definitely if we take oath to for this conserving the water, so we can create a chain and we can save the huge amount of water for our upcoming generation, right? Now, as I have said, that the most important part of this conservation of water, that is rainwater harvesting. So there is so there are two types of there are two methods through which we can conserve the water. First one is the this rooftop rainwater harvesting, and the second one is the runoff surface runoff harvesting. So this through which this rooftop rainwater harvesting, we can conserve the water for the school, offices, building with some huge large areas. And this is the just a demonstration. You can see this is the rooftop area, and this is the girder where all the water is collected through this girder and storage in this tank. Right. Similarly, we can also collect in this by digging the land with the special technique like V wire or simple just digging through bore and means inserting the pebbles and sand, and by filtering this we can also recharge our groundwater. So through which this storage tank we can utilize this water for gardening or washing of car or toilet flushing kind of thing, and then through which we can by the using of this digging or recharging facility, we can conserve the water for our upcoming years, right? So for the rooftop rainwater harvesting, there are a number of methods, as I have said that. So the direct storage method, where we can directly store the water and we utilize in the future as per our requirement. Second is recharge pit. So through this, we are after collecting and filtration of, we can recharge our aquifer. And third one is a percolation tank. This is also we can dig or with a specific surface or radius, and through which we can also recharge the aquifer. And last one is the recharge well. In this method, we just bore the land and insert the circular ring, and after inserting the circular ring, we insert the pebbles and sand kind of material through. So after filtration, it means our aquifer again recharge through this method. And the next one is the surface runoff harvesting. So in this, we can see the different areas where the contour bunding or check dams and percolation pond and recharge trenches. So these are the some another methods through which we can recharge for a large area like agricultural land or rural area or open land scan. So through which we can also protect the environment by this. By collecting this water and enhance the availability of water. This is you can see the image, and this is a girder, and this is a roof area where the after means collection of rainwater that is pouring in this girder, and through this pipe we can collect this water in this tank. Similarly, you can see this through this girder we can collect this water into this biggest tank, and after filtration we can utilize this water for the many use, for gardening purpose or cleaning purpose, or there are various use. This is the picture where we can see the different portion we can insert the thing for the rainwater harvesting. Generally, the rainwater harvesting created by the specific radial like 5 by 8, 5 dia, and the 8th depth of this hole, right? So we can insert this pebbles and coarse sand and gravels for the filtration of this rooftop water, and after filtering, it goes into the aquifer. And once it goes to the aquifer, we can actually we are conserving the water for our upcoming future, right? So in this figure, you can see after collection and filtering of this water, we can utilize this water for gardening purpose, for cloth washing, toilet flushing, car washing, right? And after also this, we can also utilize for the groundwater recharging. So there are various area we can utilize this water and reduce the abstraction of borewell, because in every we are residing in Raipur, Chhattisgarh, and every summer area actually this area is in critical zone. I will also explain what is this critical zone or overexploited area. So every summer area we are facing some issues for this availability of water. So and even in the area where I am residing, there is no proper rainwater harvesting system is there, because many people they are just purchasing the land or making a home without proper taking the what we can say the permission from the government, or there is no such a RERA approved or TNC kind of thing. So they are facing there is no proper drainage system, there is no proper rainwater harvesting system. So definitely this kind of will face in the water scarcity in the future. We have to aware with these things, and also make aware the people for this conservation of water. If you're not aware or not make the peoples aware for these things, so we'll suffer. We only not only the I will suffer. Definitely, all the people. We all will suffer for this scarcity of water, right? Either maybe you are from Gujarat, maybe you are from Tamil Nadu, maybe if you are from Bangalore. So we have to think about that. So this is also example of this trench kind of thing where we can take the large area, and after collecting this rainwater, we can utilize this water for many purposes, right? Now, as I said, how as individual person, how can save the water? So turn off the tap while brushing teeth or washing dishes. Avoid running water unnecessary. See in the childhood, हमने बचपन में देखा कि दूरदर्शन में भी ये ऐड आता था कि भैया चाइल्ड ये आप नल बंद करो, ठीक है? But till now, I have to present these things to aware the people, because I don't know why the people not bothering about this water scarcity. Second one is the use buckets instead of showers, right? That is one of the things we can also conserve the water, and then fix leakage promptly. Dripping tap can waste up to 20 liter a day, as I have said, that the industries or household just drop by drop continuously flowing, then people don't bother about this flowing of water, because why them? Because they are not chargeable for the people, so they was wasting the water, right? Reuse RO water. So many peoples are using RO water, and for getting of 1 liter, around 5 liter of water is wastage, around approximately. So that water we can also utilize for the gardening or washing of cars or any other person. But the things that should be, the TDS should be low. That also need to check. And plant drought resistant species. So we have to grow that kind of plant कि वो आपका जो that water that be water resistance, right? ऐसा नहीं कि आपने नीलगिरी का पेड़ अपने एरिया में लगा लिया, that will be create a huge problem for your water availability, right? Now the industries and agriculture practice will see how industries following and what they can do. So as per government policy, the industries should run their industry with the ZLD policies, right? So ZLD, that means zero liquid discharge. If they are abstracting the water from the borewell or carrying the water from the surface like river or from somewhere, they have to use and utilize and recycle again and again, right? So without means after treating maybe they may use HTP or ETP. If they have a residential area, they should have the HTP, and if they are definitely they are, because they are industry, so they should have the ETP. So they should have the proper treatment techniques, and after treatment they should follow this ZLD. Only this ZLDs we can or industry, or we can conserve the water, right? But unfortunately, the industries not following these things, because there are many reasons. As I had the financial point, as second one, there is two part in the financial part. पहला ये कि इंडस्ट्री वो अपने पैसे सेव करना चाहती है, and second one is that the small industries are there for that it is very difficult to install the high equipments like RO system or any. So there is very difficult. For that case, the government need to support the industries to by giving the subsidies. So earlier in 1980s or 1990s, the government means they have tried to give subsidies for installation of HT, but now the things have been changed. Now I'm not blaming the government, because if you see there are many they are taking there are various kind of taxes, but what are their responsibilities of, right? So we are actually distracting from this topic. Now the next one is water audit. So from the last 2 to 3 years, the government their care is very high, or very sincerely the government is looking at this scarcity of this water. So in India, only till now the 46 water auditors are there, and one of the auditor I am from the Ministry of Jal Shakti. So our duty is to visit the industries, and we are also checking the how much water they are abstracting, whether they have the NOCs are there, and they have the proper flow meters are there. So we after looking these things, we create the report and submit the government. So these things we'll understand tomorrow. We have a lecture in this topic, water is. So that will understand tomorrow in details, right? And cooling tower optimization. So this is another portion. If you see the different industries are there, total 17 red light or red alert areas of these industries are categorized by the government, where thermal power plant is using a huge amount of water, around 80 to 84%. So in that case, they have some means either technology or some system or some sustainable process through which you minimize the uses of water. Like as per the CGW, Central Ground Board Authority, they are just pushing the industries to what I can say, the for utilizing the household water. For example, there are a colony, so government pushes for the either you can create a STP through the Nagarpalika Nigam, or just industry can make STP. And if suppose industry can means, create a STP or making STP, so the colonies water they are treating after treatment, this water can be utilizing in diseases. That's also thinking about the government, and even the abroad or foreign, this kind of technology they are using to conserve the water. So also in India, this kind of things they have to think about that. And the next one is the process water reuse. So recycle water in manufacturing cycle. So there are various indices that they have to utilize the water again and again. And not only the utilizing of the spark, but also they have to think about the dry process, because some of industries are there. They are utilization some dry process instead of cooling process, right? Because in the cooling tower or cooling process technology, if you say the efficiency wise, the definitely the heat transfer coefficient of water is high. So so for the cooling the water is used, but if you use the air, so definitely the heat transfer coefficient of the air is low. So at that, if you so at the same time, if you want to use the air instead of water but for cooling, so we need for extra area or extra radius or some extra time. So these are the reason the industries are not entertaining these things, because industries they want only profit only, right? Now we'll see the agricultural approaches. Now we can see that the agricultural areas, they are farming through the flooding or canals water. They are not using the smart technique through which they can conserve the water, like drip irrigation or mulching technique, or some smart technique like once the any land of particular farm is filled with this water, there's some with the IoT technologies or some this AI technique, they should have the they should get the information and turn out this pump or some information through which conserve the water. So this kind of things also we think about for the conserving the waters in this agriculture area, right? And you can see this this is the drip irrigation through which we can conserve the water, a huge amount of water. And this is a mulching process where this is a sheet, and this seed is utilizing to grow this plant, because if we use this seed, a moisture get retained in this inside this soil. So moisture get humid, and the plant they may get the more efficient or sufficient water to grow. So this is again the peoples are using these things to not only for the conserving water, but also for the growth of the plant. This is the technology through which mobile phone or AI based, as I said, that the peoples can utilize the thing and conserve the means wastage of water. Now that we see the case study and some success stories are there in India, around it, even not in India, also in the worldwide. Chennai rainwater harvesting mandate. Government paid rooftop rainwater harvesting compulsory. Right. So this kind of thing should do for the every state, and not if the government. I think if the government not mandate the thing, so the people should do their own self, right? And the results, the significant rise in ground level across the city in this Chennai area. Israel efficient irrigation system, pioneer drip irrigation technology. So they are Israel country. They are using drip irrigation, and they are achieving or not only collecting or achieving or saving the huge amount of water, but also increase their productivity. And similarly in Rajasthan, India, mm, earlier they have their own their oldest or traditional technology through which they are conserving the water, like this khadins the area. They are just digging the area like pond and conserving the water, and after conserving they can utilize this water for the different purpose. And next one is this khadin, that is also the technique through which they conserve the water. This is the hilly area through which just we are and digging this catchment area, and after collecting this water we can again utilize these things, right? And then the Singapore new water project is there. So they are using advanced wastewater treatment through which they are means utilizing the cities water for the different purpose, right? Like flushes or gardening and some many are various area, right? Now we have to think about also the what are the government rules and policies for the conservation of this water, right? So the national water policy says that the framework to promote sustainable water use and equitable distribution. The government have taken some initiatives. These are the policies through which the we are at some situation uh, that we have reduced the abstracting the borewell. Later on I will show how the government policies are fruitful for this saving the water, right? And second one is the awareness campaign. So every industry should means have policies or through the government that they should have a they should have a training program or conservation program to save the water. So similarly, the government emphasizes for all the school and colleges and infra and mining all the area for this this awareness program. And the next one is incentives and subsidies. Support for rainwater harvesting system, drip irrigation, and water efficient technology. Government also support for this rainwater harvesting system that depends upon the state-wise regulation on groundwater use. Government also implemented some rules and regulation for abstracting the water. Even if you are from means for industries or from what we can say the infra or some mining. So there is a rule to you have to take the NOC from the CGWA. After only the getting the NOC, you can abstract the water. Otherwise, there will be a huge penalty, right? And the next one is the urban planning measures. So mandating rainwater harvesting in building and promoting wastewater recycling. See, there are various contractor builders are there creating huge number of infra, but they are earlier they didn't bother about this conservation of water. But now the as per the government policies, the infra now they are working on it, and at the same time they are conserving the water. Now we'll see the national water policy for rainwater. Under this national water policy, there are various schemes like Mission Amrit and Atal Bhujal Yojana are there, through which governments are working for the conservation of water, right? So the national water policy refers to the government of India's guiding framework for planning, development, conservation, and management of water resources. Rainwater harvesting is a key component of this policy to ensure water security and groundwater sustainability. And what is the national water policy says? That says about the especially for the they are focusing on the rainwater harvesting, right? So it started in the 2002 and continually some after amendment from the 2000 it's running the same concept or focusing the same planning, development, conservation, and management of water. So mandatory rainwater harvesting that is already stated by the government of India, and encourage this mandatory rainwater in urban building, government offices, educational institute, industries, and commercial. I think as the government are very strict for this taxes, so similarly they should also serious about this rainwater harvesting. So they should give the notice and penalties to these urban buildings, government offices, educational institute, industry, and the commercial area. Only through which, if they didn't these penalties or this punishment, so people not bother about these things. So now government has to stick for this, only through which now, and many states have incorporated this into the building bylaw. Integration with the national mission, as I have said, that there are various missions launched by the Indian government. That is the Jal Shakti Abhiyan, that is launched in 2019. Second is Atal Bhujal Yojana, that is also comes under the Ministry of Jal Shakti in 2020, Amrut in 2050, and a Smart City Mission in 2015. So what is Jal Shakti Abhiyan? So this is, as I have said, that this Jal Shakti Abhiyan comes under the Ministry of Jal Shakti, and the main focus of this Jal Shakti Abhiyan is the conservation of water, re-innovation of this traditional and other water bodies like ponds, tanks, and Johad, like as Rajasthan is using. And similarly, they are creating intensive afforestation or watershed development and the reuse and recharge of bore water. So these are the focus area for the Ministry of Jal Shakti through this Jal Shakti Abhiyan. And we have also participated for this Abhiyan and conserve the water. Atal Bhujal Yojana is again a flagship program of the ministry, from the Ministry of Jal Shakti, and also focused on the sustainable groundwater management through the community participation, water budgeting, and demand side management in water stretched area. So water stretched area, that is there where the groundwater table, that is also get decreased at maximum level, and as per government rules, there is completely banned for this area for abstracting the water, like Punjab or Haryana area. That all these are in red category. That red category state. And the next one is Amrut. Amrut is also a flagship urban development mission of Government of India, aimed at ensuring a universal water supply, sewerage management, stormwater drainage, sustainable urban water system. So the earlier two were for the rainwater harvesting or management or for the groundwater, but this Amrut is for not only for the conservation water but also for the treatment of water. So by using or implemented of HTPs or ATPs in the area. And next one is the smart city mission. Definitely the smart city will come, so the technologies will come, and through this technology we can optimize our uses of water, and we can conserve the water. So these are the area through where the governments are working, and we have to also participate in this area. If we'll talk about the incentives and subsidies for this this conservation of area, conservation of water. So drip or sprinkler irrigation subsidy around 50 to 75%. That is also depend upon the state wise given by the government under the Pradhan Mantri Krishi Sinchai Yojana. And till now, you can see that during the 16-17 funds allocated at Pradhan Mantri Krishi Sinchai Yojana, rupees 2340 crore, and 8 lakh hectare has been targeted under the micro irrigation. So governments are working in this area, but the things in actual practice, that is different. If we'll conclude up till now so far the presentation. So these things are why the water is necessary, or conserving the water. That is, without water, we all are aware with that is difficult to survive, right? And scarcity is definitely real, because the billions of already faces the shortage, and demand is already rising. And if the conservation part is also said that they're very essential, because the day by day the population is increasing and the demand is high. And for the conservation of water, we should have take the responsibility for the individual level, not only for that is responsibility for government or industries or any. We have to take the responsibility from yourself and the only that we can conserve the water, and we can ensure or secure the future for our upcoming generation. So this part of this presentation is just a basic level of presentation. Now I will just start presentation for aspect of this industrial point of view, or the as per the CGWB, right? What are their steps they have taken, and the area they are conserving. So looking for that. See this part. This part we have skipped. Okay. See, if you see we'll talk about the India or worldwide. We have worldwide we have the total precipitation is 388 billion cubic meter. So the meaning of this precipitation, we are talking about the surface water. Sorry, the both water, surface and groundwater. And if you see the total availability of water, and after this utilizable water resources, we have two parts: surface water and groundwater. So surface water, as per calculation, uh, of CGWB, 690 billion cubic meter, and the groundwater is available up to the 437 billion cubic meter. So uh, we have limited sources of water, like surface water, groundwater, frozen water, rainwater. So only we can utilize these two area for our purpose, like this majorly for this groundwater or for surface. We are dependent on these two major area, right? And in two major area, we have this amount of limited water. So we have to conserve this water and save water through the using or utilizing, through the recycle, through the treatment, and many area. So as I said that there are three major areas: agriculture, industries, and domestic. So you can see the percentage of uses of water, around 70 to 90% of water that is utilized by the agriculture, right? And the second number is in the industry, that is approx 16% of water utilizing, and then the rest are the domestic, and it's 14%. So see, the huge amount of water is utilizing, because definitely if you're not using this water in this agriculture, how we can survive without food, right? Say at the same time, food and water is both are important. But see, the seriousness of government of for the conserving water, that for the industries, that is only utilizing the 16%. So we have to definitely focus on this agricultural area, where major quanta of water is utilizing, right? And apart from the remaining major uses of water, we can see that the food, cooking process, hydroelectricity production, washing, hygiene, sanitation, extinguishing fires, recreations, and water transportation. These are the many other areas where water uses are there. See, this overall India has been divided for the number of blocks, that way as per the CGWB, and that blocks is called units, and total number of units are there 6553. So this 6553 units again divided in the five subcategory, like overexploited, critical, semi-critical, safe, and saline. So the meaning of this overexploited, critical, and semi-critical, what is the meaning of it? I will show you first of all. So if you see the what is the meaning of safe? The safe meaning is the groundwater use is sustainable, and you can extract the water without issue. And the next one is the semi-critical. So the semi-critical is the some stress or warning signal. Carefully management needed. And the critical, the area is under stress. Addition of fresh extraction likely risky, right? And overexploited, the meaning of overexploited is aquifer is being overused, and depletion, drop of water level, and risk of damage. And saline water, even if quantity may appear adequate, quality is to make water unusable for many uses. So saline water के लिए definitely, so yes, the five categories are there. So you can see in this figure the red overexploited area, that are this in this Punjab or Haryana side, where that area is overexploited, and because the farming is so high in this area, So the area is in the overexploited area. So we will see this overexploited and critical area. So as per government norms and policies, you can't extract the water from the bore as per the CGWB, right? But the peoples are extracting the water without NOC and without permission, right? But there are many penalties, but uh, they have multiple options to how to save yourself, right? For that, government have to not should be the lenient, but they have to type for this situation. And the semi-critical around 698 units are there, and this figure is feeling good, like we are in all around 4,793 units are in the safe zone, and the saline area where we can't use the water, that is 127, right? So there is also one rule: if you are abstracting the water and you are getting the saline water, so at the same time you have to inform the government for you are getting the saline. So one more very good or curious part, that is, suppose if you are residing in this safe area and you have a infra or mining or industry, so you have to give a charge that depends upon the quanta of water you are extracting. And but if you are extracting the saline water, so you don't want to, well, you do not have to pay the government. So that's a rule, right, as per the CGWA. Now you can see these numbers. Assessment units, that is Punjab, Rajasthan, that is in the overexploited area. The percentage is 76%, right? Similarly, in Rajasthan, in 71.552, Delhi 38.24, Haryana 61. So this is the percentage where they are in the overexploited area. See how suddenly we reach this kind of things. पहले आया ग्रीन रेवुलेशन करते हैं, फिर व्हाइट रेवुलेशन करेंगे, पहले प्लांटेशन कर लेते हैं, फिर गाय ले आते हैं, फिर नाउ द नेक्स्ट पार्ट फॉर द blue revelation, right? So that time what will happen, what was happen, that the peoples are it's creating number of bores, and so you can see the figures in this 1950, 1960, 1970, 1980, 1990, 1995. You can see the this tube well, how this the number of years increasing the tube well. So is this kind of increasing the tube well or bore well, it is very difficult to survive the conserve the water or in this aquifer. So this graph is evidence for the it's proof of the or you can say the responsibility that should be taken by the government, and they have not a strict rule till now. Even they have the penalties, but they are not strict about that. That's why the things are increasing. But now the CGWB or CGWA, they are working on it, and they have reduced the what we can say the specific consumption of water. What is the specific consumption? A specific consumption of water, that is cubic meter per ton of production, that we'll also see. Okay, this part we can just okay, we will not talk about this this parameter water management. Okay, see, in the previous decades, the peoples are aware with this conservation of water, like in Gujarat, Rani ki Bhav, where there were a huge amount of water they can save. With the Khajana Bhavidi, they beat the area where they can conserving the water. Steepville in Jodhpur, you can see, and Ritpur Steepville in Maharashtra. These are the and then Lim in Satara in Maharashtra, and the Janjira Fort in Raigad district, Maharashtra, Water Palace in Fort in India, water filtration chamber. So these are the evidence that the people they are aware of for the conservation of water. So we are in the situation in 2025, so we should also think about that, and we can also because we have a new technologies to conserve the water. So similarly, we are in the stage of advanced level, so we can conserve the water efficiently more and more, right? And also you can see the traditional water harvesting structure like khadins, tanka, micro catchment area, improved nadi, berry, water body, adjoining berry. So these are the traditional techniques through which the peoples were conserving the water, right? Okay, we'll not talk about these things. We have talked about this water footprint. Okay, so as I have said that government are working in this area of this water conservation. So one of the major bodies is the CGWA. So what is the role of this CGWA for the conservation of water that we'll see in this slide? CGWA monitors water level regime 4 times a year through a set of NHNS wells, dug wells, and piezoelectric equipments. Monitors water quality once in a year from the same NHS well. These data were immense important in understanding the groundwater scenario, development and management of groundwater in the country. So as per the CGWB policies or rule, if you are industries or if you have a mining or if you have infra, so first of all you before the abstracting the water, at the beginning you should take NOC from the CGW. Previous that is now the system has been changed, and there is an app or the website where you can apply for the NOC. The app name is No Cap, and the previous one and last year these things have been changed, and now you can apply in the Bhune app, where you can after application you can get the what we can say the NOC for the abstracting the water. So in this three area where there need to take the permission from the CGWA, that is as I said, that the industry, infra, and mining. And also there is a rule as per the CGWA, they have to conduct the audit once in a year for the industry, and twice after 2 years once in for the mining, and for infra every year. But that depends upon the you are in which area. Suppose for example you are in the overexploited area or semi-critical area, so you have to do the twice or once in a year. Otherwise, you have to do the audit in a thrice, means after completion of 3 years once, right? So that depends upon the situation, but you have to do the audit for your industries or infra or mining. These things already we have seen the yojanas of this Indian government. Okay. Okay, this slide you can see there are various sectors, and as I said, there are various sectors where the water is being utilized by the industries, like in the approximately 17 categorized by the government of India, where the huge amount of water is utilizing, like steel industries and textile industry and pulp and paper industries, engineering, sugar, fertilizers, and some other industries are there. But you can see the maximum, as I've said that the earlier slide, thermal power plants, they are around 80 to 90% of water utilizing for the production of water. So in that case, both for not only for the government, also the industrial person should think about for these things, and implemented some new technologies or sustainable technologies and optimizes this uses of water, right? But both the things are very important. Not only the water, but also at the same time, industries are also important for the as we can say the steel industries or sugar industries or textile, and so all industries are very important. But only we have to conserve the water by utilizing the techniques or advancements, right? Some have also mentioned some points where the different industries can conserve the water, like thermal power plants. They can use advanced cooling technologies. Instead of utilizing the water for the cooling, they can utilize the cool air. Similarly, the recycling of water. Next one is the pulp and paper industries. So for the pulp and paper industry, reducing water in pulping process, they have to reduce the water by utilizing of different techniques like AME or ETPs and reusing it. Okay. And the next one is the textile industry, so water efficient dyeing and finishing processes. Now the Bangladesh is using some technique where they are using dry dyeing technique. They are not using a single drop of water for dyeing the cloths. So similar kind of things have to think about the industries, right? Next one is the iron and steel industries, enhancing water recycling and reduce water in cooling systems. So this in both the area they have industries have to work for conserving the water. Scope for better water management, right? So how can the water can be conserved apart from the technologies, the water audits. So if the industries or government emphasizes this for the water audits, definitely by the doing the audits, identifying area means the identify the industry or the person can identify the quanta of water, how much water they are utilizing or wasting, right? So the water audits is one of the major weapon to quantify or conserve the water. Next one is the wastewater treatment and the reuse. So using the STP, ETP, and advanced treatment technologies and utilities like AME or and some ZLD technique, industry can conserve the water. Then technology innovation like ZLD system, the industries have to focus on this ZLD system for the this conservation of water and policy and the regulation. So government should have this. They should have take the strict action if the industries or any commercials if they're not following the rules and regulation for conservation of water. So this is also a major important rule, if you'll say, for the behalf of government and the awareness and training programs. So this is also not only for the say the government side. We should also aware of this conservation of water and how because we know that the importance of water and even the schools or colleges they should have this training program like today's program where the peoples can aware of the understand the importance of water and also understand the how can they conserve the water not only in large scale but they can conserve the water from their own homes or individual levels and also they can promote the sustainability of future even not only for this kind of program but also for some they can uh, start some events or quizzes or some program where the people understand the situation and try to conserve the water. Now, the industries, how they are conserving the water, we can see the advanced cooling system. In thermal power plant, these plants are significantly water users, primarily for cooling. By adopting advanced cooling technologies like dry cooling, hybrid cooling system, or using air cooling instead of water, plants can drastically reduce the water. So, a thermal power plants in India implemented a hybrid cooling system. तो जैसे इंडस्ट्रीज का जो इशू था कि भैया आप वाटर का आप एयर का ज्यादा यूज नहीं कर पाएंगे क्योंकि आप यूज कर रहे हैं तो आपकी कॉस्टिंग बढ़ रही है या फिर एरिया ज्यादा आपको रिक्वायरमेंट है सो फॉर दिस sorting to this reason we can use the hybrid system to for a better conservation of water. Then the few industries are using this hybrid system and reduce up to the 70% of water. Now the pulp and paper industry, water is heavily used in the pulp and paper making processes. So techniques like dry debarking and advanced washing and reducing water in bleaching can minimize water use. So these things we'll see in the upcoming slides means tomorrow's lecture. What is the right debarking? What are the technologies can be utilized by, or things can be utilized by the industry to industries, where they can conserve the water. That we'll see also in the water audit part. And a paper mill in the Finland introduced a closed loop water recycling system, cutting water usage by 50% and reducing effluent discharge. So what is closed loop water recycling? That means if you are abstracting the water from the borewell, so that borewell you are pumping and sending the water storage, where after storage you are sending in the demineralization plant, and after sending the cooling, and some of water is get evaporated. So they should have some technologies or things where they can condense again utilize, and remaining part of the wastewater that should be utilized through the STPs or ATPs, and finally again utilized in the industries. So this is a closed loop system through which industries can conserve the water. Water efficient technologies, textile industries. The industries is known for its high water usage in dyeing and fishing process. Implementing low liquor ratio dyeing machine and waterless dyeing technologies can make a significant difference. A textile company in Bangladesh adopted waterless dyeing technology, saving up to 70% water used in traditional dyeing process. तो ये देख के तो ठीक लग रहा है, समझ में आ रहा है कि now the peoples are the countries adopting the things to conserve or understand how the means what the importance of water, right? Enhanced water recycling, iron and steel industry. Recycling water in cooling and process stages is crucial. Upgrading to closed loop water system can lead to substantial water conservation. A steel plant in Germany installed a closed loop cooling system, reducing fresh water intake by 90% and promoting zero discharge. I have already visited the many steel industries. They are also adopting this closed loop system, because they don't need some means specific kind of ATP for the treatment, because still in only metal parts are remaining. So they create instead of ATP, they are neutralization peat, where after means treating in neutralization peat, again utilizing the water for like in industry or for dust suppression or for gardening purpose. The major sector we have already seen that in the year of 2000, and now we are in the 2025, and the projected year for the 2025, the total quanta of water for the industry, irrigation, and household. So you can see this what we can say, this figure 605 and 675 and 637 for this irrigation. So CGW actually working on this. So their target that the quanta of water that can utilize in agriculture, that can be how means we can decrease this. So government is also working on that, and similarly in the industries you can also see that in the different census or different years, and you can see the power plant is used in huge amount of water. So every industries have their specific water consumption. So we can see this this figure. 1 minute. See this figure, this total specific water consumption. So you can see the as I had said that the kiloliter per production of per metric ton. So that is decreasing year by year. In the year of 17 to 18, that were 4.8, and for we are counting average value of all industries 4.8, and in 1819 4.1, in 1920 3.9, and 2021 3, and 21 to 22 this reached up to 3 kiloliter per metric ton of production. So now as per CGW, this CGWA falls under the CGWA. So CGWA is working on the reduction of using of water, and they have achieved the means this specific consumption of water. That is very big achievement, and government also working on that, how they can how they can conserve or reserve the water by increasing the production. So you can see the production is increasing, but at the same time, this graph shows that the usage of water in industries is getting decreased. So, just I'm finishing my presentation. So if you have any query or question, please you can ask.
Thank you very much, sir.
Thank you.
Participants, if anyone has any query, you can ask.
Dr. Vijyendra, thank you for your nice presentation. I am Sanjay from Marwari University, Rajkot.
Yes, please.
So, in the starting, you said that world war will happen due to the water scarcity. In the starting of the presentation, is it possible?
See, this nature have a very beautiful rule. If you create a problem, at the same time you will get a result. Similarly, if the development is getting high, if we talk about in the area of industrialization or agriculture point of view, so you can see the area where droughts or floods are yearly you can see. So the nature is beautiful and their rule is beautiful. So I think there is a very less possibility for this situation.
Because 97% of water is available in the seawater, and many Arabian countries are using the desalination process, and they are using that one.
They are using saline water by treating the technology desalination, but that technique is very costlier. So that is not affordable for all countries or for our means individual level. So that is very difficult. So that's why we are talking about the conservation of water.
Okay. Is there any other advanced technologies available to add also for the less cost to treat the water, seawater?
Some countries like I forgot I think Germany. They have created their technology, membrane technology, where they are converting the saline water into desaline water. So the things have been invented, but as I've said, that the things are very costly. So the instrument has means the developed.
Even in the in the Gujarat also in the Mundra region, the power plant we have, right? And all the water they are using from the seawater only, and they are
Okay.
converting the seawater to the normal water, and that they are using in the power plant.
Okay, so
So
may I ask what is the cost? What is the per liter cost of this desalination process?
the cost, I don't know that. Once I visited that one for the industry
Okay.
visit purpose, I've taken to a
Okay.
students there.
Because I mean, see these things is very curious for me because without talking cost, that is very difficult to
Yes,
give
I know
the
that.
yes.
That is the Adani power plant. I visited
Okay.
that one. So they have
Mm.
explained that all the water they're using from the seawater only, and then converting into the normal water, and they're using in the power plant. Again, they're recycling or they're doing that one. For zero waste, they are doing that.
Yes, I can understand the situation, but no, actual, if you'll talk about I'm actually specifically not focusing of any person, but if you'll physically visit and see the things, how much water actually they are converting to run the industries. That is very important part. If you'll talk about the
Yes.
Adani's.
Yeah. Okay. That's all from my side.
Okay, thank you.
Thank you.
Yes, anyone has any question? Yes, participants, anyone has question? Please ask.
Sir, I have a question.
Please,
Hello, am I audible?
please. Yes, please.
Okay. Actually, what we are saying that rainwater harvesting in Chennai, it is already become mandatory by the made by the government. But is it possible to in the already built infrastructure? Is it feasible? That is, if, that is a new infrastructure must be needed for the rainwater harvesting. But in the already built infrastructure, how it will be possible to do the rainwater harvesting?
See, that depends upon the availability of area. For example, we have suppose any already created an infrastructure. So for recharging of the aquifer, we should have a proper dia or length of this rainwater harvesting system, right? Like we are generally used for 5/8. So in that case, what we can do that we can create some very narrow dig or points where we can collect the water and create the system for filtration of water, and we can recharge. So, but the things is the possibility is there.
Okay, sir. Okay.
Yes, anyone else has any question?
Dr. Vijyendra, can I get your contact number so that I can talk? I have some other question also, but I can talk you later also. Can I get your contact number? Is it possible?
Yes, you can. I will share your. Okay, you just share your number. I will send you, or otherwise you can collect the number from Dr. Susma.
Okay, okay. Thank you
Yes,
very
sir.
much.
I will definitely share your
Sure.
contact.
Okay, okay. Thank you, thank you.
Good evening, sir.
Good evening.
Sir, can we recharge the borewell using sewage treatment plant effluent?
No. Because
If we have a very good permissible limits, then whether we can recharge it or not.
See, if we'll talk about specifically the STP, there is a 100% possibility for the presence of bacteria or some contamination. So, as per my information, if you are using high tech kind of STP, it is very difficult to clear the water for not only for recharging now, also for the drinking. So we can only utilize for just washing of car or dust suppression kind of things. And there is one more rule also there. If you want to use this water, you have to take permission from government. You have to contact the universities, agriculture universities, and after that only you can utilize. Not only for this recharging, we can using a horticulture area. You have to take permission. So I think this specific kind of the treatment method, as you have said, the STP, this is not possible that you can recharge this water. That is contaminated water.
Sir, if the results are after the treatment, if it is within the permissible limits, all the parameters are within the permissible limit, then whether we can do or we have to discharge into a nearby water body. That is the question, sir.
See, if the limits are under the permissible condition, on that case, if you talk about the pH, you will talk about the TDS, you will talk about the total coliform, you talk about the some other ion balance, all are correct. Then only you can recharge. Otherwise, you are polluting the aquifer, right? Even if suppose there is area like mining, so you can't create the rainwater harvesting because there is a leaching issues. Yeah, some areas there is a garbage or some other things are there. You can't create the rainwater harvesting because there is leaching issues. and you can create or pollute the you can create the pollution of this aquifer. So if the all the things are under permissible level, then only with the permission, not not by your means will, only with the permission you can recharge. Otherwise, but the rule is only you can use in horticulture or dust suppression by taking the permission. But there is no direct rule to use in recharging of this water, right?
Okay,
I'm
sir.
talking
Okay,
about
sir.
the rule, right?
Okay, sir. Okay. Thank you, sir.
Yes, anyone has any question again? Participants, anyone has question? Okay, it seems no one has any question. So, on the behalf of FDP organizing team, I thank Dr. Vijyendra Kumar sir for the valuable addition and give insightful thoughts regarding water conservation. Sir, you are very well explained the water usage and water demand currently we have in the society, and how we can save the water and how the water resources are used in our day-to-day life. Also in industry and agriculture, how we have to use the water and how we have to treat the water. The entire thing is very well explained by the sir. Sir also explained various government rules and policies regarding rainwater harvesting, including national water policies for rainwater harvesting. Sir also explained the different water conservation strategies that are used worldwide and in India also. So I thank, on behalf of entire team, I thank Dr. Vijendra Kumar sir for giving such a brief introduction and such a brief talk about water conservation. Thank you, sir.
Thank you.
So today's all these two sessions are end here. So I declare that today's session is over, and I request all the participants to kindly join tomorrow on the same time with to the session. The Google link will be provided in advance to all the participants in WhatsApp link. Thank you all. Thank you, sir.
Thank you.
All participants are requested kindly left the meeting. Today's session is over. अब इसमें